Hello friends, so welcome to our channel. So today we are going to discuss about Dockers, and it will be a theoretical analysis that what exactly Dockers are and why industry is leaning towards containerization or microservices or Dockers. The Dockers is actually a application, or I will say it's a tool for containerization concept. So what is containerization concept? What is microservices? We will discuss in this video. So this video will be a theoretical video, and we will be focusing on the conceptualization and what exactly Dockers are, and what are its benefits and how it is different from the traditional systems. Alright. So when we talk about Dockers was initially a Google project, and in 2009 or in 2010 it made it public, right? And after that the most of the development is going on Dockers by some of the communities and by the Docker itself. So when we talk about Dockers, how it is different from the traditional system and what is its architecture, I will explain that. So when we talk about the traditional systems, for example, here is a example of one virtual machine deployment, and here is a example of a container deployment, right? So what exactly different is, we have a hardware, and we have operating system. On top of operating system we have a hypervisor, right? To run any application or to run different application, we need different virtual machines. So these guest OS is also one virtual machine, and some Java application or some Python application or some other PHP application is running on top of it. Now there is some another application, and it requires some different binaries or different RPMs, and the RPMs have some different dependencies. For that you need to install a different OS machine, right? And so on. So even if it's a bare metal deployment, we can remove the hypervisor layer, and there will be only one guest OS and one application, right? So basically container resolves the problem of these dependencies and uploading so many packages on your system, right? So when we talk about containers, so containers is itself has all the dependencies resolved. Containers is actually, or the Docker is actually comes in a form of an image. In a layman language, all the dependencies and all the requirements and all the things that is needed to run any application is bundled inside one image, right? So the portability of Dockers is very good. For example, my application, it requires a Java 7 to run, and my other application requires Java 8 to run, right? In the traditional systems, I cannot deploy it on one OS host, right? I have to acquire a license of another OS, or I have to take some Red Hat subscription or CentOS subscription, and then I have to deploy my application. But it's not a case with the containerization. You only need a one operating system, and then you have to run a Docker engine, and then on top of it you can deploy any number of instances based on capacity of your system, right? So this is a basic concept of Dockers, and this is how it is different from the traditional systems. So when we talk about main benefits of Docker, so most important one is size. So consider an example. I have a PHP application that also needs some Tomcat or anything else to run, and it might run on a specific PHP version, right? My application is supported by some certain PHP version. So I need to deploy the entire operating system and some of the packages are required by kernel, and some of the packages are required by some other dependencies. Some of the packages are required by operating system itself, right? So the image size or the operating system size will come, if I talk about the minimum installation, then the size would be around 2 to 3 GBs of the disk space will be captured, right? But consider a point when my PHP application only has those packages which are actually required to run, right? So the size will be very small. So when you talk about the size, so it only has a binary which is required. So the size of a Docker image is very less as compared to the operating system running application. And another example which I have just shared, a portability. For example, I want to run one application which requires Java 7, and I need an application that requires Java 8, and this cannot be achieved on a traditional operating system in architecture. I need to deploy a different virtual machines, or if I am talking about the bare metal deployment, I have to acquire a different bare metal for that, right? But this is not a case in containerization. Because all the dependencies or the Java or the binary which is required by one application, it is stored itself in the image. So when you have an image 1 which has all the dependency of Java 8 application, and you have an image 2, all the dependency are there in the Java 7 application, then you just need a Docker engine, and then you can deploy your application on top of the Docker engine, and it will run very smoothly, right? So this is a major portability is a major benefit of containerization or Dockers. So it resolves a major problem which is there in the industry, because whenever you change, for example, you are co-locating some application, right? You are bundling or you are coupling some applications. For example, your application is a Java based application, and it also required some database, but the database version on which it is running, it is different, and your jar file is required to run on some different versions. So what you have to do, you are totally stuck, or you have to then you need to convert your application based on the application in which your database is running, or vice versa. So this was a major issue in the industry, and the lot of hardware resources were wasted due to this problem, right? So the portability is a main thing which is there in the microservices concept, which resolves some major problems, right? And the package dependency that we have already discussed, sorry. And now this Docker is very easy to scale and boot up. So Docker image, where the Docker image stores all the binaries and data inside it, right? So it is you can say it is a standalone image, right? You can deploy various services which are called instances, or you can say various containers which are deployed on various hosts or on the single host, right? So whenever you have downloaded the image, or you have captured the image in your environment, then it's quite easy to start a Docker service, because it is just like a service. You just need to start a certain image, and you have to just specify the name of the container ID, and it starts. And the boot time is also less. For example, if you compare it with the operating system boot up, then everything loads into the kernel, and it takes too much time, right? But when you talk about Docker, so it is just like a service, or it is just like a daemon. It starts in no time. But it also depends on the application part, but it is just like a service, right? So you don't need to follow all the boot up which is there in the operating system, right? So also one major thing is there, that the Docker has a very good online repository support. For example, there are various 3PPs like Apache, PHP, or anything else which is there. So the repository or the online support is very strong. So you can download the ready-made images of various versions of Dockers, and then you can just kickstart your work. You can just start running your Dockers, right? And also the search is also very easy. For example, I have one sorry So for example, I will show you how I can search. Simply I can search an image in a Docker for my requirement, right? So if I see what all images are there in my system, right? So this is a Postgres or Java or Ubuntu, and some basic images are there. And for example, I want to deploy Apache on my system, so I just need to type sudo docker search Apache. Sorry. So I think my Docker engine is not running. Oh, it's running. Oh, I think it's not reachable. I need to mention. So when we run a search, Docker search, so it contacts the online repository. So my internet was not working. So now it also demonstrates that this data is not on the local machine. So it has searched the Docker's entire repository, entire online repository, and it has that what all images are there online which has Apache on it. For example, if you see this last image, it has Apache with PHP, right? And this has HTTPD and Tomcat with Apache. So it's just fetching the Apache keyword, right? So this HTTP and various versions of Apache with the PHP. So all support is there, and you can just simply pull that image from your repository. We will be covering all the details of Docker images and Docker instances or Docker containers in our coming videos. So you can just check for updates, and you can also subscribe to our channel. Yes, so I have just done the Docker pull. Sorry, I need to mention HTTPD. Right, so it has it has taken the latest HTTP version which is available online, and now it is downloading it on my local machine. So once it will be downloaded, right, so I can just simply run sudo docker images. So you can see HTTP version is already there, right? So this was a little bit of theory. Please subscribe to our channel and look for some other videos. So we will be covering basic and the advanced level of Dockers and containerization in this whole tutorial. So this tutorial will be around of around 2 hours, and you will be able to crack any interview, or you can start working on Dockers or containers after this, right? So thank you very much. Thank you for your time, and please subscribe to our channel.